In this lab, we'll be talking about standard template library, specifically standard template library lists. We've been using the standard template library for a while now. Previously, we had done templating using it. You've actually been doing standard template library strings since CS110, and you might not have even known they're part of the STL. But the standard template library is considered to be one of the most important features for C++ because it will contain very useful features, very useful shortcuts, and just structures that make your coding easier. At the core of the standard template library are essentially four foundational items. We have containers, iterators, algorithms, and function objects. So a container is basically just an object that holds data or other objects. There's several types. You could have a vector, which is basically a dynamic array. You could have queues and stacks, which you'll learn about in future labs. And this lab will be learning about lists, which are essentially an unsorted doubly linked list. So they can be traversed either from the front or the back. And each container has their own set of functions on how to use them. And iterators, an object that's more or less a pointer. They are how you traverse through the list or other data structures. You can think of an iterator maybe kind of like an array index, but not quite, because they have to travel in order. You can't just drop one in the middle of the list. So they have to iterate through the structure to get to where you want to reference. An algorithm just acts on the contents of the containers, such as a sorting algorithm. If you type in sort, it sorts the list. And function objects are objects overloaded operators that are sometimes used to modify containers' behaviors. So some points about the STL list container. It'll implement a classic list data structure that is bidirectional, meaning you can go either forward or backwards. Unlike the array, you can't just drop an index in by subscript. You have to have traveled from the front or the back to a point. It'll be defined as a template class, meaning that you can customize it to hold an object of any type. It will start as an unsorted list and be treated like an unsorted list, but there are functions to sort it. So if we wanted a simple example of an STL list, we could take this example. What it will do is it will create a list of type int. A value of 10 is assigned here, -3 assigned here. And it's going to push back these values into the list. Pushing back means it's pushing them from the back of the list forward. So this will be at the top of our list because it's at the top and everything's pushed back. So value 1 being 10 makes 10 the front. It'll be pushed forward as -3 is inserted after it. That'll both be pushed forward as 5 is inserted. And they'll all be pushed forward again with 1 inserted. And then in this sort of printout loop, we get the value of the front, and we start popping them from front to back. So that looks like this. So this is the back of our list. These were all pushed forward as we push things in from the back, and then we're starting from the front and popping them from the front, so 10 minus 3, 5, 1. Note that you need to include the list library here at the top. So right there. So there's some member functions you should be aware of before you start working with STL lists. You can get the size by using size type size constant. This just returns how many items are in the list. The bool empty just tells you if the list is empty or not. So pushing back and pushing front. If you're unfamiliar with what pushing means, essentially, if you push from the front, you add something to the top and move all the items that were already there down. If you push from the back, you're adding something to the bottom and pushing everything that was already there up. You can add items and push in that way from either side at any point you would like. front and back obtains a reference to either the first or the last element of the list. Begin and end are what you use to actually get iterators that reference the beginning or end of the list. And the iterators are how you travel through them, so that's how you set up the loop to go through your list and look at the items. Insert will take an iterator of a certain position you want it to go to, and whatever you want it to insert. And it'll iterate through that list to that point you give. And it'll insert the value before the element if there was already one at that position. Erase will erase an item at that position. Clear just deletes the entire list. Pop front and pop back we already talked about. That's how you add items and push. Sorry, popping them is taking them out. So, whereas pushing elements was adding them to the front or back, popping them will bring them out of the front or the back and erase them. So it will either, if you pop the front, it would delete whatever's at the top of the list. If you pop the back, it deletes whatever at the bottom of the list. Remove will erase everything that has equal to that value. So if you had multiple things with a 15 in the list, it would delete all the 15s. Sort will just sort the entire list in ascending order, and reverse flips all the contents of the list. So we have another example here that can demonstrate a couple of those. So what's happening with this one is it's pushing random numbers into the back. It's creating a list iterator P that gets a reference to the beginning of the list. And then while P is not at the end, it's going through and just printing out what's in the list. After that, the list will get sorted. And again, P is set back to the beginning and it iterates through printing everything out. So essentially, it's going to make a random list, show you what the numbers are, then sort it, then show you what the numbers are again. So here's our original random number list. And it just looked a little funny there because it was dropping down to the next line, but here's the sorted contents.